GCSE Physics boosters, refraction. We've talked about reflection, now we're going to talk about refraction. And this pencil looks a bit weird in the middle because the light coming from it is refracting when it leaves the water, when it leaves the glass, it is refracting. So when a ray of light goes from one medium to another, with a different optical density, its speed changes. When a ray of light is traveling in air, and if it goes into glass, then it will slow down because the glass is more optically dense. Okay, when it leaves the glass and goes back into air, then it speeds up again. Okay, so for example, if a ray of light goes from air to glass, it slows down. Now, if it enters at an angle, an angle to the normal, remember this dotted line on the diagram is called the normal. Normal just means perpendicular, it means at right angles. And if it enters at an angle to the normal, then it changes direction. And that is called refraction. That's what refraction is. Okay, notice that when it goes into the glass at an angle, it bends towards the normal, and when it leaves the glass, it bends away from the normal. Remember, less dense to more dense towards the normal, more dense to less dense away from the normal. Look at this, see if you can figure this out. Now, when an observer looks into the water, he sees the fish, but he doesn't see it where it is. He sees an image of the fish. Okay, can you explain why using a diagram? So pause the video, have a think about it. I'll show you the answer in 1, 2, 3. Okay, so the fish is giving off light in all directions, but some of it will end up in this bloke's eyes. Now, the light that ends up in this bloke's eyes will take this path. And basically, when it leaves the water, it will refract away from the normal. And the ray of light will do this kind of changing direction as it leaves the water, going into the guy's eyes. Now, this bloke's brain thinks that light travels in straight lines. So his brain thinks that the light is coming from, well, behind the fish. If you look at the dotted line, and what he actually sees is a virtual image of the fish. We'll talk about different types of image later when we do lenses, but he sees a virtual image of the fish where his brain thinks the ray is coming from. More refraction. We talked about in a previous video, and if you haven't seen it, you should watch it because it's dead good. About P waves and S waves, and as they travel through the Earth. Now, as they travel through the mantle, they curve. Why do they curve when they go into the mantle? And also, the ones that enter the outer core, when there's a sudden change of direction when they enter the outer core, why is that? And you should know, as they enter the mantle gets more dense and they refract. And then as they enter the outer core, there's a sudden change in density. So you get a lot of refraction. Now, you need to know these diagrams. These aren't ray diagrams. These are wavefront diagrams. And I won't do my joke about Wavefronts. I'll save that for my classes. But these are wavefront diagrams. Now, this represents waves going from air into water, or air into glass, something more dense, a more dense medium. Now, the frequency doesn't change. The frequency is the number of waves every second. That can't change. We're not creating or losing waves. So the frequency doesn't change, but the wave slows down. So because of that, the wavefronts have to get closer together because they have to travel less distance in the same time so they get closer together. Now these waves are entering normally, along the normal. What happens if they enter at an angle? Then they do this kind of thing. If the wave fronts enter at an angle, then the wave changes direction, i.e. it refracts. And why? Because on any particular wavefront, part of the wavefront will slow down first. One way of thinking about it is if a Land Rover enters a muddy field at an angle, then the wheels on the right hand side will slow down first, so it will swing round. So because it slows down, that's why it changes direction. If you remember, why does the wave change direction? Because it slows down. That will get the marks. And by the way, you might have to draw something like this diagram, this second diagram. Look at this. This is some white light. Could be from a light bulb, could be sunlight going into a glass prism. And notice that it changes direction, it refracts when it enters the prism and when it leaves the prism. And something interesting is happening on a screen over there. We're seeing the magical elf, Roy G. Biv. And that's actually called dispersion. Okay. Isaac Newton basically said that this shows that white light is made up of lots of different colors, 7 different colors. Okay, it's called dispersion. What I'm interested in now is just the fact that it changes direction. Now, why? Because imagine this, imagine we had a couple of them prisms and maybe just a block in the middle. Then look what's happening to these rays of light. We can make them come together, we can make them arrive at the same point. And in fact, if we use a piece of glass which is shaped like a lentil, it's lenticular, in fact let's call it a lens, then we can bring lots and lots of light to focus on the same point. So lenses use refraction. That's what lenses are all about, and we're going to spend a whole big video talking about lenses. And this is a converging lens, okay, a convex lens.